Alright, okay, earlier what we had was this relationship a to the power b equals to c, let's say, right? So this we call index form, or sometimes it's just exponential form. Okay, so the meaning of exponential is index. Exponent means the index, alright? Okay, so that's why what we want to look at right now is this thing called logarithm. Okay, now basically logarithm is just another way to rewrite this exponential form. Okay, rewrite this index form. Okay, right, so logarithm as in, so if you write that, it will become log c base a equals b. This is how it's written. Okay, so if you look at this, what is this a called? A is called the base. Alright? A is called the base, right? So when you do it in index form, it's the base raised to whatever index. Yeah? The number a is the base. And in logarithmic form, in this log form, you write a as a subscript. You write log, and then that a is a subscript. A subscript is just a small little letter or number underneath. Okay? I will go through the calculator later. Alright? So you need to use a calculator on this, or you may need to use a calculator. Alright? And then that b there is called the index. Okay? Or the exponent. Okay? Alright? So and then this c, you can call it like a solution. Alright? So this is how log is written as. Alright? Alright, so what you have also, like for instance, let's say 2 to the power of 5 equals
Wait, no.
2 to the power of 5 is
2 times 2 times 2. I was about to say that.
So if you're going to rewrite this in log form, logarithmic form, or simply we just call log, so it would be log 32 base 2 equals 5. Okay? Now, the proper way to read this is this way. Log 32 base 2 equals 5. Okay? I know many of you just read from left to right. So log 32 equals 5. Whatever. Okay? But the proper way to read is log 32 base 2 equals 5. So it's like if you read again, begin 2 raised to the power of 5 equals 32. Right? So that's the same way how it's written. Alright? Yes?
What's the purpose?
It's manipulation. The basic idea of log is to turn a very large number into smaller number. For instance, let's say 2 to the power of 5, you're working with 32. So 32 is relatively big number. But if you look at log, you only work at number 5. So you are turning 2 digits into 1 digit. You're turning the tens of number into 2. Okay? I'll show you another one. Let's say you have 10 to the power 6 equal how many? 0, 1, 3, 4, 5, 6, right? So if you write log here, 1, 2, 3, 4, 5, 6, base 10 equals 6. Instead of doing 6 zeros there, you work with 6 only, the number 6. So you're turning a relatively large number to a relatively small number to work on. Okay? So that was a very simple idea how log is used. Okay? So here, it's only if it is base 10, because we work a lot in decimals, right? So all our numbers is decimal, yes? Decimal means every 10 you move in to the next digit, yes? Yeah? 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it becomes 2 digit, yes? Right? So that's called decimal system, right? Those doing computer. What other system are you, what number is, you have binary, right? Binary means 1 plus 1 equal 10. There's no 2s, there's no 3, no 4, no 5s. Right? Okay? So 1 plus 1 is 10. Okay? So that's different way of doing that. Now if it is the base of 10, you can write this as LG. So this is exactly the same as that. 1, 2, 3, 4, 5, 6 equals 6. Okay? Only if the base is 10, instead of writing LOG subscript of 1, 0, you write LG. Okay? Right?
So sir, only for 10.
Only for 10. Okay? Right. So the next thing that we want to look at is how do you use that, how do you use calculator? How do you key in the calculator? Now for instance, if you have, let's say 10 to the power of x equals to 3, let's say. So how do you do this? Now first of all, of course, you rewrite this in log. So this in log will be LG, which is base 10, yes? What is the index? The index is x, and the solution is that 3, right? Okay? So it's LG3 equals to x. So how do you key in the calculator? So in the calculator, you look for this button, LOG. You key in, you tap that button, and you tap 3, and then you can tap your equal, and it should give you whatever that answer is. Alright? 0.477 something, right? Okay? 477? Okay, 4771, right? So it's just this. Okay? If you have log 10, what does that equal? 1, huh? 10? Cannot. No need to use calculator. 10 to the power of what number give you 10? Okay. Alright, that's the idea. If you have log 10 to the power of 2, what does that equal?
2.
2, very simple. If you have log 10 to the power half, what does that equal?
0.5.
Okay, it's a half, 0.5. That's the same number. Okay? Alright? Now, one thing to note is that the base, when we do log, that base must be greater than 0. Okay? So we usually, that base, we just look at whole number. Alright? There wouldn't be anything that says log base 2.5. Usually no. We're just not working on those things. Alright? Let's say, we're not working on these things. Alright? So our definition of logarithm is that this number must be positive. Okay? Which also means there is no such thing as this. Okay? No such thing. Alright? So we're not working on those things. Okay? Ken?